Welcome to The Explainer. Today, we are diving deep into the shadows of digital communication. We're talking about the art of sending messages that are not just encrypted, but, well, completely invisible. This is a level of secrecy that's way beyond scrambling a message. It's about hiding the fact that a message was ever sent in the first place.
So, let's start with a puzzle. Imagine you have to get a critical message to an ally, but you know you're being watched. Every single email you send is being read, every call is monitored. How do you communicate? You can't just encrypt it, right? Because the very existence of that garbled, encrypted file is a huge red flag. The real trick, the real challenge, is to talk without anyone even noticing you're moving your lips.
And the answer to that puzzle is something called a covert channel. And yes, it is a technique straight out of a spy thriller, but I promise you it is very, very real. It's all about hiding the entire conversation in plain sight.
Okay, so let's get this straight, because the difference is really important. Normal encryption, that's like putting your letter inside a locked box. Everyone can see you sent a box, they just have no idea what's inside. A covert channel is something else entirely. It's more like smuggling a message by changing the rhythm of your footsteps as you walk past a guard. The guard sees you walking, totally normal, but they're completely oblivious that a message is actually being transmitted. It hides the communication itself.
Now, what's really fascinating here is that if you actually wanted to build one of these channels, you've basically got two main methods to choose from. You can think of them as two different flavors of digital spycraft.
So on one hand, you have what are called storage-based channels. This is where you and your contact have access to the same shared digital space, maybe a file on a server somewhere. The sender then encodes a message by making tiny, almost unnoticeable changes to that file. But on the other hand, you have timing-based channels, and these are, arguably even more subtle. With these, you use time itself as your messenger.
And we're going to focus on that second idea, because using time to communicate is just this truly elegant kind of mind-bending concept. It literally turns the empty spaces, the silence between normal, everyday digital activity, into the message itself.
So here's the absolute key. To any outside observer, everything, and I mean everything, has to look completely normal. Just random network chatter, regular system processes, nothing can look out of place. The entire secret depends on keeping up this illusion. So how in the world does this actually work? Well, here's the basic recipe, and it's surprisingly simple in principle. All you really need is a secret, a clock, and some network traffic that nobody would ever look at twice. Let's walk through it. Okay, first things first. You take your secret message, let's use the word test, and you translate it into binary. The fundamental on-off, 1 and 0 language of all computers. So your word test now becomes this long string of 1s and 0s. Next, and this is crucial, the sender and receiver have to agree on a simple rule ahead of time. This is their secret handshake. So, for example, they might decide that a 0 in the binary message will be represented by a short pause, and a 1 will mean a much longer pause. Simple, right? All right, showtime. The transmission begins. Now, to anyone watching, this just looks like one computer checking if another one is online. It's a ping, a totally routine network event that happens millions of times a day. This first ping is just a heads up, basically saying, get your stopwatch ready, the message is starting.
Now, our message test starts with the binary digit 0, and according to their secret rule, that means a short delay. So the sender waits for just a fraction of a second, and then sends another identical, completely harmless-looking ping. The receiver, on the other end, who's timing everything, sees that only 0.2 seconds went by, so they write down a 0. The first bit is received.
So what's next? The next digit in our binary message is a 1. So this time, the sender waits for a noticeably longer period, let's say just over 5 seconds.
And then that third ping is sent. Again, to anyone monitoring, this just looks like a bit of random network lag, nothing to see here. But the receiver, they measure that delay, see that it was a long one, and they jot down a 1.
And that, right there, is the core idea. It's brilliant. The receiver isn't analyzing the content of the pings at all. Those packets are totally empty of any secret data. Instead, they are measuring the silence between them. By carefully timing these gaps, they can perfectly reconstruct that string of 1s and 0s and, poof, they have the original secret message test.
So now that we kind of get the how, let's talk for a minute about the why. Because as you can probably guess, a tool this powerful and this sneaky is a classic double-edged sword. Its purpose really depends on whose hands it's in. On the one hand, for some people, these hidden channels are an absolutely vital lifeline. Think about investigative journalists trying to protect their sources from powerful people, or whistleblowers exposing corruption who would be in serious danger if their communications were found. For them, a covert channel might be the only safe way to get the truth out.
But there's the other hand. For cybersecurity professionals, these channels are a total nightmare. Imagine a malicious insider using a timing channel to slowly leak sensitive company secrets or government data bit by bit. It would completely bypass all the fancy firewalls and security systems designed to stop exactly that kind of thing.
And this really gets us to the heart of the matter. The very nature of a covert channel makes it incredibly hard to defend against. I mean, think about it. How do you even begin to monitor for something that's designed to look like random, normal background noise? Just understanding that these methods exist is the first crucial step, both for protecting legitimate secrets and for detecting these kinds of malicious threats.
Which leaves us with a pretty provocative final thought. As our world gets more and more connected and more monitored, the desire for true privacy isn't going away, it's just going to get stronger. So the real question isn't if new, even more clever covert channels will be invented. The question is, where will we find them next? In the blinking lights of your Wi-Fi router? The changing speed of your computer's fan? The shadows of communication are vast, and human ingenuity is pretty much endless.